explore in terms of equilibrium is what's known as the equilibrium constant. And the equilibrium constant is simply the letter K, capital K. And it tells us really how likely a reaction is to go in the forward direction or how likely it is to go in the reverse direction. And if we had some fake equation, let's just say A number of compound A plus B number of compound B, and it was in equilibrium with C number of compound C and D number of compound D. So our capital letters are representing elements, molecules, and our lowercase letters are representing coefficients. So K is always equal to the concentration of C, one of our products, raised to its coefficient, times the concentration of our other product raised to its coefficient, all divided by our reactants. So A raised to its coefficient times B raised to its coefficient. So that is the form of the equilibrium constant. And the equilibrium constant is that K right there. So for an example, if we wanted the equilibrium constant for this equation up here, we simply have K equals, I'm going to come over here and look at my NH3, or ammonia is my product. So I'm going to want the concentration of NH3 squared all over the product of nitrogen. And because that's a coefficient of 1, I'm not going to put a 1, but it's nitrogen to the first, times hydrogen to the third. Alright? So if I gave you numbers, and I'm going to give you numbers in just a second, we would plug them in and see what the K value is for this particular reaction. Alright? A couple things before we do a little bit of math. If K is larger than 1, okay, it means something. So you need to know that if K is larger than 1, it means that this reaction is product favored. So it tends to go in the normal direction, alright, from left to right. So again, it's product favored. And if you just think mathematically, we have products over reactants. So if we have a large number, something bigger than 1, our denominator, or our numerator on the top has to be larger than our denominator on the bottom. So if our numerator is larger, it means that we have lots of our product. Okay, that's why it is big. Why is it big? It's big at the expense of our reactants reacting and getting much smaller. Alright? The converse is also true. If K is less than 1, it is reactant favored, or it tends to go in the reverse reaction instead of in the forward reaction. And again, that makes sense, because if we have a small number, it means our denominator is large and our numerator is small. So why is our denominator large? Because our reaction is making more of our reactants than our products. We have a lot of reactants and very few products. And if we have small divided by big, we get a small number. Okay? So, if I said at equilibrium, we have, I'm just going to throw out some numbers, let's say 0.2 molar nitrogen. And we have 0.4 molar hydrogen. And we have 0.6 molar ammonia. Alright? So if we wanted to find out what K was, then you could tell me whether it's product or reverse, or product or reactant favored, or forward or reverse favored. We're simply going to substitute our molarities into our equation. So we're simply going to find that K equals 0.6 squared all over 0.2 times 0.4 cubed. So we're going to simplify this a little bit. So 0.6 squared is going to be 0.36. And then we're going to have 0.2 in the denominator. And then 4 raised to the third. Well, 4 times 4 is 16 times 4 is 64. It's going to be 0.064. Alright? And we can simplify this a little bit more. 0.36. We're going to double that, move our decimal one place over, so 0.0128. And then I need a calculator to do this last part. So we're going to pull one up and find out what 0.36 divided by 0.0128 equals. And we find that it equals 28.1. So if it equals 28.1, that is greater than 1, so we can say that this is forward favored or product favored. And that is what we want.